Hi, this is Jason Molesky. In this example, we'll construct a confidence interval for a population proportion. The Gallup Youth Survey asked a random sample of 439 U.S. teens aged 13 to 17 whether they thought young people should wait to have sex until marriage. Of that sample, 246 said yes. We'd like to construct and interpret a 95% confidence interval for the proportion of all teens who would say yes if asked this question. We'll use our three-step process, starting with stating the problem. We want to estimate the true proportion P of all 13 to 17-year-olds in the United States who would say that young people should wait to have sex until they get married with 95% confidence. Now to plan, we should use a one-sample Z interval for P if the conditions are satisfied. Recall we should check three conditions. First, the randomness condition. Gallup surveyed a random sample of 439 U.S. teens, so this condition is met. Next, 10%. Because Gallup is sampling without replacement, we need to check the 10% condition. There are at least 10 times 439 or 4,390 U.S. teens aged 13 to 17, so this condition is met. Finally, we need to check our normality condition or our large counts condition. We check that the counts of successes and failures are both greater than 10. In this case, the number of successes, n times p hat, was 246. That's greater than 10. And n times 1 minus p hat, or the number of failures of 193, is also greater than 10, so this condition is met. So, a 95% confidence interval for p would be given by this formula. P hat plus and minus our critical value z star times the standard error of our sampling distribution. In this case, the square root of p hat times 1 minus p hat over n. Our sample proportion p hat was 0.56. Since we're building a 95% confidence interval, we'll use a critical value of 1.96, and the standard error can be found by multiplying 0.56 times 0.4, divide by our sample size 439, and take the square root of that result. Working this out, we get 0.56 plus and minus 0.046, which works out to an interval from 0.514 to 0.606. So to conclude, we are 95% confident that the interval from 0.514 to 0.606 captures the true proportion of 13 to 17-year-olds in the United States who would say that teens should wait until marriage to have sex. In other words, we estimate that approximately somewhere between 51.4% and 60.6% would capture the true proportion of 13 to 17-year-olds in the U.S. who would answer that question with a yes. For practice a confidence interval for P, try exercise 39.